If X is on the left, I feel like X is the equation, it's equal one.
Ellipses and hyperbolas, yeah. Always. Divide by 4.
What happens if it equals negative numbers?
Divide by the negative number.
So I'm only gonna get it smart.
Oh,
Like so.
that is a degenerate conic section, like an X point. It's not a big shape.
How would you solve for the degenerate?
We don't do it. No.
You have extra calculators in case we forget them.
It's for another class, but if you.
Oh my God, this is thoughtful. That is thoughtful. That is thoughtful.
Like this on and.
Perfect. No calculator. No calculator.
So I did it on a piece of paper, but I brought the paper. I didn't bring my test.
And you don't have the post-it notes?
No, I just did it on a different piece of paper.
Or tomorrow, make sure it's on a post-it note directly fastened to your.
It's for A, and then X. And then this, and then B for like Y direction, but it's like A is bigger than B and it's underneath. Maybe.
See, folks. Time for quiz study is. Have a seat, everybody. Over your phone should be in here. May not. Oh. Yeah. That was so close. Oh, man. It's low.
Yeah. You did?
Class has begun. If you have your test corrections, thank you for bringing them up. So good morning. I was asked when the test is, and I realized I haven't given you a date. I didn't put it on the hub, so let's take a look and figure this out. Where are we today? Which day here?
Day 4.
Day 4.
It's kind of day 4.
Day 4.
Let's see. So day 4 is this is Monday, so 11.6 is going to be
Tuesday. Wednesday.
11.7 Friday. TBA.
Monday.
On Tuesday.
The Wednesday.
We did that. Remember, we did that right before break. So we don't have that TBA now. So so then
Friday. Friday.
so after Friday. So
Next Friday.
here's Friday this week. And this is
Wednesday.
Tuesday.
We have class.
Oh, yeah.
So Wednesday.
Okay, Wednesday and then Friday. Next Friday is.
We're out of school Tuesday.
Oh, that's nice.
It's like why old man can use call this weekend when they would pay off.
Got what?
Like a free weekend.
Oh, interesting. Nice. A mini free weekend.
Yeah.
Okay.
So it's next Friday.
It's done.
Did you say?
Yeah, one day.
You turn it.
So today.
Yeah, today.
Wait.
3 by 3. Last time we did hyperbola with a little introduction to I don't know if you've ever done 3 by 3. So we're
I
gonna.
don't know what it's about.
We're just grinding my calculator. Like now.
Today is this one. Next time, when is the?
Be good.
A lot of chatter going on today.
We're all just so excited for the quiz.
I don't blame you.
Like Nancy.
There's probably too much chatter. Thank you. Who's missing today?
Julian.
Julian.
So he was.
Hopefully he'll be coming in soon. We'll see.
Maybe he went to the wrong class. Maybe he was so
Maybe he went to
excited.
Coachella. Maybe he went to Coachella.
Catch the last act on Monday. Never know. Okay, so in any case, one final thing about conic sections is they're interestingly enough, and I think many of you may already know that they are found in nature, all three, really four of them. They're all found in nature with respect to gravity. Would you please take a moment to discuss, like, where would you find conic sections in nature with respect to gravity?
Yeah.
Oh, yeah. Obviously, like this. Okay, fine, but it's a thing that we could. Yeah. Here.
What's in the? What's the list?
If there was a naturally forming cone and then like a naturally forming plate and went through it, then it would be natural.
Like,
Yeah, but it could.
well, yeah. or gravity lines.
Nature is a beautiful thing. It's a miracle of life. Whatnot. Our problems are always. That's on the test. Direct.
Yeah, that's a great.
Maybe they'll ask you like acceptable questions. Like, what's the distance of live spectrum? Lattice rectum. So that's the distance from the directrix and this one, right? Yeah, perpendicular to that.
Okay. So, any ideas? Yes, Lauren.
Celestial bodies.
Are we good with that?
Yeah.
Orbits of celestial bodies. That's nice and said. Anything that is in orbit would be an ellipse. And of course, a special type of ellipse is called a circle. If the major and minor axes are the same, then it could be circular, but it's definitely an ellipse. And let's say we're talking about the Earth around the sun. So our path around the sun is an ellipse. It's elliptical. It's close to circular, but it's elliptical. Where would the sun be on that ellipse?
Okay.
It'd be one of the foci. Not the center, it's one of the foci.
Yes.
Another relevant like asteroid or something.
It's random. There's nothing there. There might be like something coincidentally there, but one of the foci has to be the gravity attracting object. Yeah, that's the big one for ellipses. Oh, it wasn't here. Parabolas or hyperbolas. Yeah. Oh, if you throw something,
Say.
right, the trajectory is
Probably
parabola, unless you have a super strong arm,
goes out of orbit.
Or it
then
goes-
maybe it becomes an ellipse.
Oh, yeah.
Yeah.
I think it goes all the way.
Maybe, I don't know. Yeah, probably parabola. Yes, okay.
There's like a double rainbow, you can consider that hyperbola.
Is the rainbow hyperbola?
I don't.
Yeah, the double, like you can see two arches.
Size, yeah.
Oh, really? Oh,
One rainbows.
Like one,
Yeah.
like one, two,
should be a
left.
circle.
They're styling.
No.
The hyperbolic rainbow.
Might be too proud.
I was talking more about gravity. I'm not sure about optometrics or light refraction. I don't know, but I think that would be circular, specifically double rainbow. I just don't know enough. Interesting to think about that. Yeah, but definitely something that's thrown, unless of course there's wind, but something that's thrown in a vacuum would follow the trajectory would be that of a parabola. Something like that. But a hyperbola, where would that be?
Nowhere.
In a reflect.
In a reflection. Well, I'm talking about gravity here.
Oh.
Where in gravity could we find a hyperbola?
Black hole.
It's a good one.
Are you conducting some music here or making hyperbola? Well, that'd be great. Hyperbolic conducting.
Oh, wait, no, it's like half of it though. Like.
It depends where you go. Depends where you go.
I feel like you can do that.
Okay, I get it. I'm trying here.
Any idea hyperbola? Okay, guys. Have you heard of, to get rocket ships going pretty fast without using a lot of rocket fuel? Like in space, once they're in space, like if we're sending something out into the outer limits of the solar system, do you know how get it going really fast? Drop? It has to release parts as it exits the atmosphere. Slingshot. Have you heard about this?
Oh, yeah.
Where it uses the gravitational pull.
It uses the gravitational pull of a planet to shoot it in some particular direction. So think about how this works. Let's say there's a planet and we want to get something going really fast with the help of that planet. If we shoot a rocket or a satellite or what, not satellite, but something at the planet, that would end in disaster.
Yeah.
Hit the planet and the mission be over. But if we shoot it in such a way that it eventually becomes susceptible to its gravitational pull, do you see what's going to happen? It's going to be pulled and sent off in that direction.
That's why.
Oh my God, a boomerang falling.
Oh, it is a boomerang.
Wait, like.
Because of the gravity.
No.
Which is half of a
Hyperbola.
hyperbola.
No.
And think about it, like when does the rocket start succumbing to the gravity of the planet? Some could say maybe immediately. Maybe immediately.
It's being dragged towards it.
It's being dragged towards negligibly in the beginning, but as it gets closer, it's gonna leave that original straight path, isn't it? And be brought in the direction of that planet and then slingshotted out into space in different direction. It's a predictable because we know that we're going towards the planet. Yes.
The planet.
Yeah.
And the planet's a focus. Yeah, exactly. Now let's say we didn't shoot strong enough to escape the gravity of the planet.
It'll crash.
Then it wouldn't crash necessarily, but then it would make an orbit,
An ellipse.
an ellipse.
What?
With still that planet being a focus. I don't know if it would maintain that kind of speed. It would probably crash into spiral into it. I'm mad, but I'm not sure. Maybe it would be elliptical. But if we have enough force, this planet could make it faster going out this way. From my understanding, which is very limited, but I just thought that's kind of an interesting place that you might see the shape of one of the conic sections. Okay. Ready to go on to systems?
Yeah.
Of course.
Let's do it. No?
Yeah.
Put on your seatbelt. Get ready for this ride because we're going.
I'm gonna miss you guys.
Raise your spot to left.
Oh, we have a quiz on it.
That's next.
Some of these may look familiar to you.
So mattress.
Some of them may not.
Matrices. Mattress.
I like the prayer one.
Guess I can.
That's a good one. That's a good one.
When in doubt, try number one.
I would do that during the class.
So, How many of these are you familiar with?
3.
4, actually.
Hopefully the top
I'll-
three,
Like five,
all five.
Yeah, all 5.
not four.
No one.
Maybe in algebra one you use this, like, let's see if
Guess
the
and check.
1 and 2, does it work? No, maybe 1 and -1, like trying to compare. That's called luck/prayer. Please let the answer come to me. That method will receive, for using that method, you will receive 0 points. Sorry, yeah.
Go up.
It's gotta be one of these three. You can't use prayer or luck as a method for solving a system of equations.
What about nature?
Nature seed is a beautiful way to solve systems of equations. That's what we're gonna do in this class.
How thank you. I don't know what that is.
Yeah, they're no.
They are, they're awesome.
So guess what I found? 6.
Now, although we don't normally use graphing, I do want to remind you that it is a method to solve systems of equations. Why don't we usually use graphing?
It takes a long time.
Takes a long time and
It's not.
It's not out of break that.
it's not super exact, right? If we're the one graphing it, it's hard to
Make it perfect.
make it perfect, but it's still an important way to solve systems of equations. So I don't know if you have a calculator, but if you do, let's just do a couple problems. Make sure you know how to use your calculator to do like this one. If you were using graphing method, what would be a good method to do this?
Set them equal, like substitution.
If you weren't using graphing
Oh.
method,
Oh, just.
Elimination.
Substitution.
I think substitution would be.
Substitution is just.
Since y is equal to this, just substitute this over here, so it's equal to each other. But we're using graphing method. If you haven't put your phone up here, please make sure you do.
They know what's my phone.
Beautiful.
Oh.
Oh. Trace. That's.
Where are you?
Oh, no, calculates, right?
1 and 3 calculate is.
The intersection is one common thread.
No, it's only supposed to be like.
Hey, after two, yeah.
Why do you want to have your done?
Look at the
It's
third.
only-
Hands up on. The intersection is one.
Did you get it?
Yeah.
What's the answer?
One common thread.
1, 3. Are we good with that?
Yeah.
Okay, let's try one more of these. But before we do, I know you have your calculator, but would you please, in your notes, don't do your calculator yet. Just in your notes, would you please make a quick sketch of y equals ln of x? And just check to make sure your neighbor remembers the basics. I want 1 point in particular, but 3 points would be nice.
I want to use it this way. There's no way you.
It looks like this.
So we should do both
And
sides.
zero, y axis.
And once you have it, go ahead and graph both on your graphic calculator.
What do you think?
How would you graph it if it's like for b, it's like x squared plus y squared equals one? Cause you can't really, just like, there's no y, but.
You have to solve this. They have y. Yeah.
But it would need to be like over y.
Yeah, there we go. I didn't think.
Oh,
No, you subtract x squared and you get square root, so you have y equals
oh,
square root of x squared minus 1.
What you said? Just my one? You say just my focus?
Where did you get that?
Focus is on her.
It's at 2.19107 column 0.7971.
Yeah.
One thing that both.
Yeah, see if you can figure it out together. I can go over it.
oh,
Here.
Here it is.
I don't have fun yet.
First curve.
There we go. Looks a better view. Yeah, we know.
And you.
Is LS the minimum?
Good question.
Yes.
Does it?
Yeah.
I'm scared, graph.
Well, yours has minimum. I don't.
For a second?
Oh, that's- My graph.
Would you give me?
I see what you're saying.
Yeah, 2.2.
Like a 2.2191, 2.219.
Yes,
You think? Radians
it is. Yeah, in general, when you're using trigonometry, use a radian.
Here.
Okay, this does look like it stops, doesn't it?
Because it has limitations.
Location.
Oh,
If I were to zoom, I can do a quick zoom.
In.
No, I'm not gonna zoom. I'm gonna change my window. I don't need to see all that. I'm gonna go to -1. And for the y values, I'll say -5. And let's see if this is any better. Still limited. It's still limited there. So I think what I need to do is change this, maybe make these smaller, point 0.01 instead of 0.04. See what, a little bit better, maybe even a little bit less than that. Oh, this is weird. X max, I want it to be more like 6. Which it's backing up. It's changing my X maxes.
I calculated it. Working.
What's that?
Calculated.
Did you calculate in radian mode?
It's in degrees.
Ah,
Yeah.
okay, so how many solutions are there? Just one solution, and should we all get the same solution?
Yeah.
Okay, let's see here, what is it?
What did I?
Looks like the X value is gonna be 2.25. 3.2.
1.
I want the whole register too.
2.21.
1.9.
107,
Yeah.
1.
like that.
Yeah.
Do we agree with this?
Yeah.
And the other one?
0.2.
797,
9.3.
749?
9.3 at the ends.
Oh, 93 at the end. Like this?
Yeah.
Did I write that correctly?
Yeah.
Yeah.
There wasn't a 3 on mine.
Oh, there wasn't, but it went to 9.
Yeah.
Okay, interesting. Now, if you didn't get something like this, you probably didn't use the right function. And what is the function I need to use here?
The second trace.
Yeah, we need to go to that calc function. So the second trace, I'm gonna hit 5. And now it's asking for the first and second curve, just because it could be up to how many curves?
10.
On our calculator, it holds up to 10 curves. So go ahead. Right. It defaults to Y1, so I'm just gonna hit enter and then enter again. And that asks for the guess, you just go near it. Enter. There it is. Do you mind match yours?
Yeah.
Yeah. looking good.
Wait, there's no one. I think his is older because his is the older one.
Wait, I'm not getting much.
Oh, no, man.
Is it okay?
Yeah, that's fine.
Good enough.
Any questions?
Oh, it was Joe.
Yeah, I got it.
Old version.
Yes, it's funky one.
Interesting.
I think
Maybe it's better.
Cool.
Those ones that were not. Those two codes almost ended the right hand one.
Okay.
So heavy.
Okay, that's why I like this.
So we're moving on from two-dimension land
What is that?
to X, Y, and Z. This is called a 3x3 system of equations. Does that make sense?
Oh, right.
No.
3x3 meaning there's three unknowns, so three equations. If you have three unknowns, you need three equations.
Wacky.
Shall we graph it?
No, yes.
If we were to graph these, do you have any idea what shape it would make?
T. A three-dimensional.
Yeah, three-dimensional shape specifically.
Triangle. Rectangle.
Wait, dodecahedron. A plane.
Ellipsoid.
Each one of these would be a plane.
Cardioid.
These are three planes.
I don't know. what
Yeah,
that
dude.
means.
Well, like the surface here is a plane.
So it's like three planes.
Three planes. Yeah, it's not like an airplane. Like, could we see an example of this room where there are three planes that intersect in one point? Or can you check with your neighbor? Three planes, three
Corner.
up anywhere where three planes intersect with one point.
No, those two has.
I see people pointing at the corners of the room. Nice. Where else?
No, that's two. One direction, two direction, three.
I like what you said. Yeah, the corner of the desk. Does that make sense? That would be the intersection of three planes? Like
This?
you're right here. Like if it were actually planes, it was. There's gonna be one point that's in common to all three. So that's what we're looking. So we're not gonna be using graphing. Do you think substitution would be helpful here?
Sorry,
Substitution, we're not gonna do substitution either.
Elimination. No.
Elimination is the way.
Nature elimination.
Just elimination. So we have to decide which variable do we want to eliminate first.
Z.
And it doesn't matter which one it is, but make sure it's easy. I think Z is a good one to do. Would X be pretty easy to eliminate?
Yeah.
X is-
Yeah.
How about Y's?
Yeah.
None of them are too bad. Let's eliminate the Z's because that's what people said first. So what you want to do is break this down from a 3x3
Put 2 by 2.
to a 2x2 by eliminating the Z's. So first thing we'll do is multiply which equation should we use first? First equation and second equation? To eliminate the Z's, we have to multiply the first one by 2. So we have 2x plus 2y minus 2z equals -2. Now that we have Z's, you may want to start putting a cross through your Z's, otherwise they'll look like
two.
twos, especially if you write like the. So we have 6x minus y equals 18. Cool. Did I do that right? Oh, 14. It's -2. Thank you. Good catch. Oh yeah, one of those little errors throw everything off. Now what?
Now you take the third equation.
First and third.
Yeah, let's use the first and third equations. And we're still eliminating the Z. Don't go switching up the variable here. We'll multiply the first one by -3.
-3, yeah.
-3?
Yeah, it could be 3 if you want to subtract an end. I like to add ultimately. Did I do that one right? 3 plus 5 equals 8. That's good. Sweet. So now we have a 2x2 system. I think you could solve that.
Oh.
You're solving the 2x2.
Can you do substitution?
You're welcome to do substitution at this point. But don't do substitution from the 3x3. Unless you
It just,
not for this one.
when it's the fractions, but if you.
So what we have to do is just.
I'm not sure. I haven't tried it. You can try it. Yeah, try it.
Am I not increment?
What's that?
Well, I cry and I try.
You'll cry anyway, so. So half of one, 6 dozen of another.
I love how you're able to acknowledge the.
Negative two.
Yeah, negative two, why is it negative two?
This is an elimination.
You should.
I'm not gonna use it. That was a mistake. Go to Blender.
Why is it good negative?
I do a mattress.
And then we have to solve for D here.
See.
Oh, wait, that's more.
You could do a pen.
Oh, it's just,
Ben can do it, but I can't.
You could do it, Natalie.
see, it's just one.
Yeah.
No,
What
yeah.
was that?
X is two. X is two, Y is negative two. It's just one.
So you got x equals 2 and y is -2, is that right?
X-
Yeah.
Are you supposed to get z?
You just plug in X and Y.
Yeah, just use any one of the equations. I recommend the easiest one that you are least likely to make a mistake. We have 2 minus 2 minus z equals -1. So what does that work out to be? Z equals 1?
Yeah.
Okay. Now for 2 by 2, you put your numbers together into an ordered pair. In this case, we're going to put it all together into an ordered
Triple.
triple
Three works.
trio. That's fine. Just put together like that in parentheses, separated by commas.
How interesting.
You want to check?
Not really.
Me neither. You could check by just substituting all 3 into each one of the equations.
No.
But I think the fact that they worked out nicely is it's good already. Is it guaranteed that solutions will always be integer values?
No,
It is not
it is hoped for.
hoped for. It's more than likely it's going to be either integer or like that, right? If you see something like a 17th, there may be an error somewhere, but maybe like a half or a third you might see. But there might be a 17th also. So usually the solutions are integer values. Yes, Sam and then Ensign.
You have a way to determine quickly slopes or whatever of the planes to see if they're all like not touching.
Interesting. Slopes, planes do have slopes, but they're a little bit difficult because rise, run, and run again or something like that. So nothing, I don't know.
So to see there's no solution, you kind of have to like.
Yeah.
Yeah.
And so did you have a question or?
You always want
If it's just a system of 3 by 3 like this, then yes, but if it's a word problem, then I want a sentence answer. And what we do now. I want the triple, I want it to go all the way. Just to recognize that it's a point, right? These are planes and points are the solution. So do these systems always have solutions?
No.
So it's possible that planes don't intersect?
Yeah.
Where's an example of that?
They are.
Like 2 pieces.
So this wall,
Yeah. Who knows?
and the wall in the next room,
Yeah. Maybe they have like a 0.1.
or 2 pieces of paper,
I don't know.
stack, and another stack, no solutions for all 3.
Yeah.
3 people, if the people are planes and they're not touching each other, ever, yeah, okay, thank you.
Or like your introverts.
Okay, so this one,
We can just
let's go for it, what should we eliminate?
the,
Z,
Definitely.
we don't need to multiply anything, do we?
for the second and third.
You could add the first and third, and you could add the second and third. Have just a nice clean, let's do that. So first plus third, I have 3x minus 3y equals -1.
Yeah.
Second and third, I have 2x minus 2y equals -8. Did I do that right?
Yeah, that's no solution. I think.
Did you already tell what's gonna happen?
Yeah.
Yeah, now, Sam, I think this is where we could say, hey, the reduced form. These are parallel, so we can say that about the whole solution. If we wanted to go through this algebraically, we can multiply the top one by 2, the bottom one by -3. Just to get these to cancel, but then everything will cancel and we'll be left with 0 equals something that's not 0.
Just do the circle with that, with the slash.
Yeah, you could do a circle with a slash. 0 equals not 0,
But
which means that this system
it's no solution.
has no solution.
Only one doesn't have to work to make the system have no solution.
Right, once you have something that's ridiculous, 0 equals some non-zero number, then you know there's no solution. Or 5 equals some non-5 number. Easy,
Yeah.
let's keep going. Da-da-da-da-da-da. What shall we eliminate?
The first and
These are the
second,
parallel.
Oh,
X, Y's, or Z's?
these.
Now, this one's gonna be a little bit more challenging, I'll let you know,
Substitution.
because in this case,
Bigger numbers.
there will be solutions.
Oh, hey.
Oh, infinite.
Not extraneous. Remember, like, the two lines could be the same line. Of course, it could be the 3 planes could be the same, but I think looking at it, you can see that they're not the same plane. Like the numbers are jumbled. But could you imagine 3 planes intersecting in such a way that there's an infinite number of solutions?
They're all laying on top of each other.
That would be the same plane then.
But if they like are
So
all
discuss with your neighbor, how could 3 planes
fit,
interact so that there's an infinite number of solutions?
that's the point thing.
Is it like, hold on, wait, no.
Yeah.
Are you saying like this, where it's like, not just something across?
Yeah, and then the other cross, yeah, exactly.
That's, oh, there is, that's so true.
Yeah. 'cause it's on that line.
It's so. tricky. There's a lot of ways that can-
So how do they intersect? These 3 planes. There's an infinite number of solutions. There are a few different ways, but the one we're looking at is, what if they all just intersect in a single line, like we have this
But
plane
that's
here,
one plane.
this plane, and then another plane coming out of this.
Yeah, so that one line.
There are other ways, we have this plane, and then a plane cutting through here. Which would result in,
Two.
there'd be 3 different, you're right, they're not touching all 3 of it, that would be 3 different ones, you're right. The only case would be where this line, if there's another plane coming out of that, then there is one line that satisfies everything. And that's what we're about to look at. It's a little bit more complicated than others, but we could do it.
So if you prove that 2 lines have infinite solution, does that mean the third one?
Oh, for the,
Yeah, like you get X and you cancel out the B and get X and Y and they're parallel or is that not?
yeah, that's what we're about to do. Yeah. Okay, so let's cancel the X's. And again, you can start with anything, but I'm gonna tell you this problem works out easier when you cancel the X's, and there's no way to know in the beginning.
The axis?
Yeah, we're gonna cancel the X's here.
Oh,
Like substitute.
So I'm gonna multiply the first one by -2. So +4. I may be misremembering it. Maybe this won't be the easiest way to do it, but that's okay. We'll work it out. So we have y plus 3z equals 7, is that right? Yeah, that's right. Now I'm gonna use the first equation and the third equation. See how to do that to eliminate the x's. Let's multiply the first one by -4. Be careful here, you know, one little error could lead to disaster.
Right.
So pray that you don't make an error.
Yeah.
Um,
Use number 5 for.
Yeah. Did I do this right?
It doesn't matter what you decide to eliminate, right?
Yeah.
But like,
can use it.
easier than the other.
Yeah. Not always though, it's just sometimes just arbitrary. I felt you're like eliminating the y's, so do that. We could have used the second and third equations to eliminate the x's, right? That would have been fairly easy, just multiply by -2. Would have been fine too. But you'll see what we're left with here
Same equation.
Same
Oh,
equation. Aren't they the same equation? We divide by 3, we have y plus 3z equals 7. Same. And when we see that, we know
We should do a weird notation thing.
infinitely many, excuse me. Infinitely many solutions. But to say that is not enough. We have to know exactly where those solutions are.
So
Well,
technically,
yeah.
you can pick any of the two lines, you just happen to choose.
Yeah.
And it's long.
Okay, so. Maybe put your pencils down for a minute, once you're caught up to this. And just watch for just a minute. So from here, the next obvious step for me is to say that y equals negative 3z plus 7, yes?
Yes.
So what z is, remember last time we said that like y is an element of all real numbers?
Yeah.
Yes. In this case, z is gonna be an element of all real numbers. But don't write anything down yet. If z is an element of all real numbers, that means we also need an expression for x in terms of z. Now, how do we do that?
Get rid of the y.
Yeah, so I'm gonna take this y and plug it into
The first equation.
any one of these equations.
The first equation.
The
Not
first
equation.
equation. Not anyone.
Now remember, our goal is to eventually have an expression for x in terms of z. So I'm gonna use the first equation and rewrite it instead of using y. And this is gonna be some work on this side. X minus 2 times negative 3z plus 7 minus z equals 8. If you want to copy, I'm gonna do some work here. Are you crossing your z's? I know it's weird.
So that was actually our
Cursive
requirement.
C instead.
What you've been doing. Ben, what'd you say?
Is that like our requirement?
It's not a requirement, just a recommendation.
Can I do cursive?
You did cursive Z? Interesting.
No.
They just looks, it bothers me to flash.
Just make it obviously different. If you already make your twos with the loop, and if you do the loop in the twos, that's also a good way to differentiate.
Same bond with you.
Yeah.
Like nobody can access you.
So you don't want to do that?
I mean, I don't really care.
So far, so good.
Yeah.
Yeah.
So what kind of notation am I gonna use to write the solution here?
Okay.
The braces. Formal set notation, so all points y z such that x equals negative 5z plus 22.
Bring X.
We have to write it.
This is what I want to see. Z equals, I'm sorry, y equals negative 3z plus 7, and z could be anything, element of all real numbers.
Must it be the is an element of all real numbers?
No, it could be x or y. So
But just put Z is equal to da da da, and then for whatever one, you can have like X.
x could be an element of all real numbers. Yeah. Which I do want to talk about this. Okay, so now that we have this, let me just review what we did. We broke it down from a 3x3 to a 2x2 and found that the two equations that we had
Same.
are the same. That's how we know there are infinitely many solutions. From there, we took the equation, solved it for one of the variables. And at that point, we decided which would be our free variable. Right? Everything would be based on that z. So we had y in terms of z, it could have been x in terms of y, or y in terms of z, it could have been anything. In this case, it was y in terms of z, which means we just needed to find out about x. So I took my y expression and plugged it into any one of the expressions. We use the easiest one to solve for that third variable. So that you'd have expressions, so you could put in here for x, y, and z. Now, if y were elements of all real numbers, you probably put x first, then z, and then y. So any questions? Yes, Sam?
Wait, sorry.
Yeah.
I think you kind of already, I'm just trying to visualize. Of course, you have like one line. And then 2 points this way. Or you have the one like a triangle.
Hmm.
Is that gonna come up?
No, we're looking for points that lie on all three planes. So all there's were like point contained in 2, but not all 3.
Yeah, that's not possible.
That's possible, but not in our scope. Question. Any other questions? Okay, we're gonna take the last 30 minutes of class, which means like right now, do our quiz. Right now.
30 or 3?
30. Okay. 3 would be very fast.
Oh, boy, here we go.
Ready, Patrick? Wait, nah, that's your.
We'll give you 2 minutes just to kind of shake it off. Relax a little bit.
Patrick, what do I need to do?
We'll start at 32. Is that what-
The end of y, it's like this, you get that.
You do not need a calculator. We'll begin in 2 minutes and 10 seconds.
Oh, sorry. You're right, you're right. You find the Fochi.
Oh, no. Crazy. Wild man. Oh, gee.
Yeah. What? What'd you put the lid? T squared equals a squared.
Bigger number.
Which one's the transversal axis? Which one's the?
I don't know. I don't. All right. Oh, boy. Then for honor code, can I just write? I did not.
Oh,
Please write down. Thanks, Brad.
What's the day? What month is April? Is it 5?
More.